Now, students, we will see something new. I'll tell you what is nth root of unity. Before that, we will see how a matrix can be written as a symmetric and a skew-symmetric matrix. And then a Hermitian matrix can be written as the sum of a Hermitian and a skew-Hermitian. Let A be equal to P plus Q, where P is half A plus A transpose and Q is half A minus A transpose. Now A, put the value of P here, half A plus half A transpose, opening the bracket. Now Q, in place of Q, you put open the bracket and put it half A minus half A transpose, and this comes out to be A. Therefore, these two expressions are valid. Now I have to show P transpose is P. So P, I take the transpose of P on both sides, and this becomes half A transpose plus A transpose transpose, which becomes A. Write it front and take it back, I get P. So P is a symmetric matrix. Similarly, Q transpose is minus Q. I have to show that. So take the transpose of Q on both sides, and I'll have half A transpose minus A transpose transpose, and this will give me A transpose minus A, which is same as minus half A minus A transpose, which is basically minus Q. So Q is Q symmetric. Now I need to prove that P plus Q, A P plus Q is a unique representation. Let A be equal to R plus S. Let us understand something else. Let R is symmetric and S is Q symmetric. So now, take the transpose on A on both sides. A transpose is R transpose plus S transpose. R being symmetric is, since R is symmetric, R transpose is R, and S is Q symmetric, S transpose is minus S. So these two ideas I have to use here. And then I'll solve these two equations, solving 1 and 2 simultaneously. I'll get R as half A plus A transpose, which is P. Similarly, S I'll get as half A minus A transpose, which is Q. So the representation is unique. Now we will similarly now the second part of the point is how to show that it is Hermitian and a skew Hermitian matrix. What you need to do is that you need to write the same thing as A is equal to P plus Q. And now P you have to write half A minus A star conjugate transpose A star, and Q as half A minus A star. This I am not doing for you. This you can do as a homework wherever ever the transpose symbol is transpose. Just a minute. Transpose. Just a minute. Transpose symbol has been used, has been used. You need to use, you need to change it by a star symbol. That's all. Rest all is remains the same. Now let us understand what is nth root of unity. Before that, I'll make you understand what is cube root of unity. Let me do it. Wait a minute. Cube root of unity. Cube root of cube root of unity means x cube is equal to 1, but x is not equal to 1. Bring this 1 on this side. X cube minus 1 is 0. Then 1 can be, and 1 cube is same as 1. 1 cube is same as 1 as, so x cube minus 1 cube is equal to 0. Use this formula that you use in smaller classes. A cube minus b cube is equal to a minus b into a square plus ab plus b square. So here it will become x minus 1, x square plus x plus 1 equal to 0. Now as x is not equal to 1, as x is not equal to 1, so x, just a minute, so x minus 1 is never 0. So x square plus x plus 1 is 0. Now, as you have seen in smaller classes, ax square plus bx plus c equal to 0. So x is equal to minus b plus minus under root b square minus 4ac by 2a. Using this, we will find the root. X is equal to, this is 1, so minus 1 plus minus under root 1 minus 4. A is also 1, c is also 1, ac upon 2. So x you will get minus 1 plus minus under root minus 3 by 2. Now let us see, I told you earlier also, uh, see, under root a plus b is never equal to under root a plus under root b, never. Under root a minus b is also never equal to under root of a minus under root of b, but under root of ab is equal to under root of a into under root of b. Similarly, under root of a by b is equal to under root of a upon under root of b. Now, here, using this concept, this concept, under root of minus 3 is same as under root of minus 1 into 3, which is under root of minus 1 into, wait, minus 1 into under root of 3. So this is basically iota, so under root of 3 iota. So x comes out to be minus 1 plus minus under root 3 iota by 2. So x has got these values. X has got value minus 1, just a minute, minus 1 plus under root 3 iota by 2, comma, minus 1 minus under root 3 iota by 2. You can write this as omega or this as omega square or omega square, omega, it hardly matters. So now, as x equal to omega comma omega square are the root of x square plus x plus 1 equal to 0. So omega square plus omega plus 1 is 0, or if you put omega square, if x is equal to omega square, then omega square whole square plus omega square plus 1 equal to 0. That is omega 4 plus omega square plus 1 is equal to 0. That is omega cube into omega, that is omega 4 plus omega square plus 1 is 0. I told you that in the beginning, I told you, see here, I told you x cube, x cube is equal to 1. So now this omega cube will be equal to 1, omega cube will be equal to 1. Therefore, this expression will become omega plus omega square plus 1 equal to 0. This is very important. This is for, now you see one more expression. You see one more expression. I think I told you once. Now see this. Let us see. Just a minute. Wait a minute. Euler's formula. Euler's formula before. Now see, e to the power of I theta is cos theta plus I sin theta, and e to the power of minus I theta is cos theta minus I sin theta. Now you see one thing. Wait a minute. Now see, cos n pi is always minus 1 to the power of n. Example, if I take cos pi, then n is 1, then I get minus 1 to the power of 1, and that is minus 1. If I take cos 2 pi, I will always get minus 1 to the power of 2, and this will give me 1. That means odd will give me minus 1 and even will give me n odd. N odd will give minus 1, and n even will give will give plus 1. Now, sine n pi is always 0. Now, let us see cos 2n plus 1 pi by 2 is always 0 for n equal to 0, 1, 2 and so on and so forth. Or in some books you will see cos 2n minus 1 pi by 2 equal to 0 for n equal to 1, 2, 3, so on and so forth. Now, if I write, sine 2n plus 1 pi by 2, see what happens. See what exactly happens. You can see now at n equal to 0, 1, 2, 3 and so on, you will get 2n plus 1, you will get as pi by 2. 2n plus 1 first you will get as 1, then 3, then 5, 7, 8, 9, 11, sorry, not 8, sorry, not 8, all odds, extremely sorry. This is 9 and then 11. At 2n plus 1 pi by 2, what you will get is, wait, you will get pi by, wait a minute, you will get pi by 2, wait, you will get pi by 2, comma 3 pi by 2, comma 5 pi by 2, comma 7 pi by 2, comma 9 pi by 2, comma 11 pi by 2. And if you write sine 2n plus 1 pi by 2, you will get 1 minus 1, 1 minus 1, 1 minus 1. So I will explain you in the next lecture why this situation happens. For the time being, I will consider the nth root of unity in the next lecture. Okay, thank you.